Hello everyone. Are you able to hear me?
Yes, we are. Good evening.
Okay, good evening. So, like, how many of you wrote the today's paper? Like, I guess Python exam was there, right? For some OPP test was there for you guys. If somebody would have taken the Python. Okay, I guess nobody was having that exam. Fine. So eighth, have you seen the content of eighth week? It's already over, right?
Yes, sir.
Okay. So I'll just okay. So today is like open session. So we'll just, if you are having any doubt regarding the whatever the questions are there, activity, practice, or credit, you can ask. So we'll discuss those. Why are you like everyone is not speaking anything?
So basically, at least for me, the whatever lectures are there, I have understood that, but while applying them, it's becoming very tough.
Oh, okay. So I'll just, can you say me some questions problem? Maybe we'll just discuss that. Maybe that will help you.
Like the activity questions for 8.2 and.
Okay, I'll just share my screen. Yeah. So which one?
So 8.2. Actually, I could solve them finally, but thing is, it was very like I had to go through them so many times. It generally doesn't happen that way, but.
Okay. So basically for this 8.3, I guess all the questions are based on the single concept, right? That is the
Right.
how generally you convert those, whatever the has been asked in the question, how generally you convert a basic probability equation to the normalized form, and then you have to apply, right? So
yeah,
that's just I can say hit and trial method. You have to just try and then you'll get. So
maybe
it's
this
just,
is a new concept altogether, and we are not used
yeah.
to it. Maybe because of that, it's happening that way. Looks like.
Yeah, but there is not much concept in this week. So in the first, like it's simply MGF, and those are pretty simple. In the second one is bit complicated and can like I can say, yeah, it's a bit difficult topic, CLT. But rest of the things are like based on distribution. So all those, I guess, is not that difficult. You just have to. There are some basics distribution that, and you should be mugging up the, what you can say.
Yeah, I mean, remembering them is like a big task.
But I guess in the exam, I guess all the formulas will be there.
No, I'm not talking about formula. The shapes of the distributions and all is too many distributions together, kind of thing. So it's like heavily packed week, kind of.
Yeah,
that's what I feel personally.
Earlier, it was like 7th and 8th week was like in a 1 week. Now you are reading 2 weeks. So this, I guess the formula that you'll get in the exam, I don't know whether this all will be there or not.
Okay.
Okay. So I'm not like this. This was for the, I guess, quiz second. For the final exam, I don't know whether they'll give you all the gamma distribution, beta distribution, and all. That maybe in the upcoming week will let you know, and accordingly you can, if you are like, those are pretty like all the distribution almost seem similar, so that you need to, what you can say, mug up the formulas.
Yeah, the only thing is, sir, I mean, the time is limited. That's why. Otherwise, there is no issue as such. It's like too much content is squeezed in too less time. That's what I feel. I mean, I don't know about what others are thinking. I'm facing that thing because I'm finding this week 8 is more difficult than any other week so far. So,
okay. So the shapes and all, what I'll just try to give you some idea. Maybe you'll already having, if you are having this type of graph, this is the first one. If you can see the x varies from 0 to 1, you can directly say it's a beta, right? Right. And if you are having some plot that is almost, what you can say, mirror image of the left and right one is mirror image, then you can say it's a normal.
Yeah.
Okay. Right. And then this type of, because this gamma generally, how generally to represent gamma. So gamma is generally a function of x which is multiplied with, I guess, the exponential, and then the result will come in this graph 4. So not graph 4 or graph. Yeah, wait, I need to write up the gamma distribution. So that there will be a bit confusion regarding gamma only, but the beta you can directly say and the normal you can directly say, I guess. Yeah.
So one query over here. I mean, I may be wrong because I have gone through lecture 3 just now, so probably I couldn't revise. That's why I'm asking this question. But in case of beta and gamma, like we are saying, beta is the first one, right? The graph 1 is beta 1 now, and the graph 4 is gamma 1. So can it be like changing the parameters? Can gamma can look like beta or beta can look like gamma? Can it happen that way? Like one thing is exponential type, right? In the graph 4, the right side is exponential type. And in the graph 1, the left side is kind of exponential type. It's going up. So that's why I'm asking. I'm getting confused over there.
Okay, so for the beta, what you can directly say, the beta for the, what you can say, the domain or the x values will vary from 0 to 1, 1. So there you can get a, like you can differentiate between beta and gamma. So for the gamma,
can you repeat? Can you please repeat that?
For the beta, the domain of x, like the x values that you will put, that will vary from 0 to 1 only. Okay, so this x will always be from 0 to 1. So there you can.
Okay. Oh, I see. Okay. Got it. Yeah. Okay.
And for the gamma, it can vary. Like it will be greater than 1. So that one differentiation, like you can.
Yeah, I didn't know that actually earlier. That's a good point. Okay. Thank you, sir.
Sir,
Yes.
I don't know about beta and gamma function. I haven't watched the lectures yet. So, like, if there are no queries further, sir, can you please explain the beta and gamma? I mean, of course, if others don't have any problems.
Okay. So, I'll just explain you. Like, I'll just go through the same slide, the professor, whatever he has used. Like, most of the thing that the distribution has not been explained in a brief way. Only the formula, like the distribution formula, how generally you represent that. Okay, so I'll just go through that. Before that, if somebody is asking, the portal is still not accessible for me, what is that issue? Like whether it's for everyone?
Sir.
Yeah, sir. Same.
No, sir. Those who have Python, for them it is
Yes,
not.
Python for OPP exam.
Oh, okay. So that, okay, I'll just ask them to resolve this as soon as possible. Right? So whoever has opted Python and was having this issue, right?
Yes, sir.
Yes, sir.
And this happens today only, right? Or it was yesterday also?
No, sir.
Yesterday it was not there. From today
OPP.
morning from onwards.
Okay. So okay, I'll just put it on the discourse. Not in the discourse. I'll just ask them what is that. Maybe from tomorrow it will be fine, because you have to submit, I guess, by Wednesday. So today is Sunday. You have time. Okay. So how to solve the problem? So which problem are you asking, Bhaskar? Can you ask, like, can you be more specific? Then maybe I'll just discuss those type of problem. So I'll just go through the beta and gamma. Okay.
Mostly like CLT problems.
Okay. So after discussing the bit about beta and gamma, I'll just go through the questions of the CLT. I'll just go through all the questions. Maybe that will help you to solve.
Yeah, sir. This will be great.
I'll just tell you how to anticipate that. Maybe for some questions, I'll just download the slide. Where is the slide for this week? What else? I'll just write it. So just take the help of the slides also. Okay. So what happened? So mostly if you are having some distribution, right? So distribution generally have some parameters, right? So if you are having some distribution, so distribution generally have like 2-3 things, maybe. So one is this, like how does this, what's the shape of that distribution? Okay, and location can be the one thing. Location of the mean or anything. Like for example, if you're having some normal distribution, so how generally define the normal? So normal should be having that mean value and that variance, right? Or maybe the distribution can have something like that shape is their location, or can we, how does it behave, like the rate of the distribution? So how does it behave now? Like the exponential generally can, if this distribution is a negative exponential, so it can fall a bit faster, right? If you are having some distribution in the form of 1 upon x, so that will fall a bit less. Like in comparison to 1 upon x, the exponential will fall a bit more fastly, right? So the rate can be the one this features of the distribution. Okay, or anything else, like one can be say location, or it can be scale also. Scale.
Hello.
Yeah. Right. So this 4 can be the like what you can say, the basic features to know regarding the distribution. Okay. Like for example, we were having the normal, right? So normal was having some parameter. Without that parameter, we can't say, like, or similar, or if you're having the Poisson distribution. So Poisson was having some lambda constant, right? So you have this type, or in the, so similarly, so this sort of distribution or the exponential or any other distribution that we have already discussed. So we have just further added some distribution. So what happened in the basic, like most of the cases in our like generally we study with the normal. So normal is like most popular, like whatever you're having, it will behave in normal, right? Suppose and we are having the exponential also. So with the observation and all, we came to know about some other distribution also. So such in those cases, we are having one is the gamma distribution. Right. So in this gamma generally can be written in this form, right? Alpha and beta, where the beta generally represents the rate and the alpha generally represents the shape of the function or the distribution. Okay. Or if like I'll say in the term of what you can say in the term of how generally you present in the form of what is the function. So this can be represented in the form of like some constant times. Okay. So this is the one way to represent, like this is the only way to represent the gamma distribution. Okay. So this is the probability density function, you can say, for the gamma distribution, that like the way generally we write for the normal distribution. Okay. So normal distribution is having a different sort of like probability distribution function generally we write, and that is a bit user one than the gamma distribution. So gamma distribution, this is the rate at which this plot is falling, right? So like for example, see if you are having alpha, let's say greater than 0, okay, and this beta also some, for example, I'm telling you for greater than 0. So this will be from how generally represent the exponential function. So exponential function generally, how generally represent that? Can somebody say how generally represent the exponential function that is falling with some beta rate? Okay, are you able to understand or not? Or should I just go through the slides?
No, sir,
Is
go
it
ahead.
decay rate that you are actually referring to?
Yeah,
The rate at which it falls?
yeah. So decaying rate only I'm saying, or the rate at which it's falling. So in the gamma distribution, generally the alpha will represent the shape. So this is how generally has been taught. Okay. So this was the 4 function. It was like just shown in the form, and sir also told how generally the distribution is varied. Like what are the features of the normal distribution, basic distribution generally we are having. So the shape, location, or the rate at which it's falling, or the scale. These are the some features. Not the all features, but these are the some features that generally defines the basic distribution. Okay. Like, so here it was just discussed about the normal. So here is the gamma. So in the gamma, generally you're having alpha and beta, where the alpha generally denotes the shape and the beta the rate at which it's decaying. Okay. And so this is the function, the basic probability density functions, where so this is how generally you differentiate between the beta and the gamma. So when you will go through the beta, so the beta will be having that x will always will lie from 0 to 1. Okay, but in the gamma process, x will always be greater than 0. So for this example, like for example, if alpha is greater than 0, the alpha is simply the shape parameter and the beta is the decaying rate, or you can say the rate at which it's falling. And these are the basic property, like the properties if you are having the distribution. So what would be the mean value and the variance and all. So how generally the gamma generally comes from the exponential itself. So if you are having n IID in like exponentially with beta as constant, after summing you'll get, like if you'll use that MGF concept, and then if you'll sum, you'll get the gamma distribution only with n as the shape and the beta as the n whatever, like how many exponential distribution you have added. Okay, so it will come in form like 1 upon 1 minus 1 upon beta. In such form it will come if you'll add up the if you'll add up n exponential distribution. Okay, if you'll use MGS, you'll get the gamma with this beta. So this is the gamma. So how, so this is the function. Like for example, this exponentially, if some function is decaying, that means what? If you'll go to the infinity, like when we'll put the x as infinity, that function will go towards the 0, right? Because the exponentially minus beta, so beta will be some constant, and that is positive. And if you'll put some, you can put some values right here. Like for example, this is the exponentially that is decaying. Like if you'll put the x as some, if x will tends to infinity, so it will go towards 0, right? And if x is towards 0, so it will be around, it will cut the function at 1. Okay, so this is the exponentially decaying function. This, and then if you are having x, like where the alpha is some sort of greater than 1, like for example alpha 2, so it will be like some this type of function, right? So if you are having this function, and where, okay, so this function, and we were having this function, and the product generally will come like this, because you can see that if you are having some two, so this is simply the multiplication of two functions x. So there is no like thing how does it came. So this is just based on like observation, or so there were many distributions. So but when you got a particular set of data, so those data generally behaves in this way, and then they gave us some name like gamma, beta. So and this was the basic, what you can say, the distribution or the probability distribution function. This way they generally represents, and this was the function like, and in the end they came up like there is no such proofs and all. How does this came and all? So you can say one proof can be they came up with like an independent exponential distribution function, and then they summed up, and then they observed that there's a different type of observation they got, and that then later they started calling them a gamma distribution. So this the one sort of distribution. So basically you need to only, what I can say is remember only like what's the, if you are having some sort of gamma distribution, how does that behave, and how does you'll get the plot and all. Okay, so plot and all, you can, after seeing the distribution function, the plot, you maybe you can distinguish between gamma, normal, or beta and all after having a bit more, what you can say, experience with going through the different distribution and all. But these things like the mean on the variance, these things you need to remember, or you can say mug up. If it's not like mugging up, maybe sometime we'll be able to already grasp this. Okay, so most important the normal, and you already remember about the normal everything. But for the gamma, beta and all, everything is not important to remember. But yeah, if you have to just solve some sort of problems and all, you need to have this sort of things in mind. Yeah.
Sir, do beta and gamma function problems come in the exam?
Yeah, it will come, but it's not difficult. Like it's almost similar to.
Sir, okay, I get that, sir. Like what you have said, like there should be a constant multiplied like with the PDF of gamma function, right, sir?
Gamma function.
You said there's a constant x raised to the power alpha minus 1, then e to the power minus
this one.
Yeah, you said k, right, at the beginning.
Yeah.
You went to the slides, sir. So now, like, how do we get to this k? Yeah. So how do we get the value of this k? Or will this be given, or like how do we do this? Find this out.
Okay, so if this type of question will be given, the k will be given, or you'll be aware of the alpha or beta, because you can't get the k if you're not knowing alpha and beta, because only one thing you know, the summation of this function will be equals to 0, like 1. Because whatever the function you're having, this distribution, whatever the distribution you're having. So the area under this curve is 1. That is the only thing you're knowing, right? You're not aware of the alpha, beta, right? Alpha, beta, or the k. So if they're giving you any questions regarding this sort of problem, so they will be giving you all the parameters regarding, because if you're being asked regarding normal distribution also, if you don't know the parameter, that is useless, right? The parameter can vary from value to value. So based on those parameters only you'll be able to. So if they are asking you anything regarding the gamma, so they'll give you everything regarding that gamma. So yeah.
Sir, is it possible to do a problem, related problem?
Related problem means whatever that is in the. Is there any questions like in the? I don't think so. There is any questions in the, I guess, that is related to gamma only. So all those things are based on application. This is the point of introducing the distribution here, is to know regarding the features or the properties of the gamma, and how does, like for example, if you are having an exponential, so that will come up to a gamma. So those sort of things, the main intuition behind this, like putting the distribution, was that. So there's not such question that will ask you regarding the only gamma or beta only.
Okay, sir, no problem. Thank you.
Yeah. So if we'll ask the gamma only on based of, okay, so I'll just see that. So this question, I guess, all are based on only plot only, because only the plot thing has been discussed there. They have not discussed anything regarding how will you get the k or alpha and beta, right? So mostly they can ask you regarding the plot only in the exam also. So which of the following plot represents a beta, or which of the following plot represents the gamma? This sort of questions can be asked.
So
So
one more
sim-
query over here. Is it
Yeah.
okay if I ask? You
Yeah.
said just now about beta and gamma, right? That beta should be between 0 to 1 and gamma will have more than 1, right? So
Yeah.
can it be like that
No,
gamma can
gamma
also
will
have
not be greater than 1, can be greater than 0. Yeah.
can
Beta
be
will
greater
be
than 0. Sorry.
0
So
between.
it can also be between 0 and 1, right? So it can be confusing as well, that beta and gamma graph. If gamma is between 0 and 1, how will I understand that whether it's a beta graph or gamma graph? Will there be any difference in that?
Okay. 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 So you are asking if so yeah. So then you can get confused. But the
Right, because
problem,
of the
yeah. So
yeah.
then, but if you're having some options, there you can distinguish between them, right?
Right.
Not given the options, because gamma can also lie, because gamma can for the gamma the domain or the value that you'll put in the x can be greater than 0. Okay, and there is
Right.
no limitation on that, because it will go till infinity, because you are multiplying with the exponential of minus beta x, right? Because if you are having only plot that is given like this, because they have not told you regarding the when the x will tends to infinity, how does that plot is behaving? Because for the gamma, because we are multiplying that decaying function, when the x will tends to infinity, that should go to 0.
Right.
The function should go to 0, right? Yeah. So like for this function, the graph 2, whenever there can be somebody can get confused between the normal and the gamma. There is no confusion between beta and gamma, right? For the graph 2.
Yeah.
Because the beta will always lie from 0 to 1.
Yeah.
So there's only confusion between normal and that gamma. The
So
confusion
won't normal be symmetric?
normal be symmetric always.
So the graph 2 is not exactly symmetric, now. So that way
Yeah.
it will not.
Okay. Yeah, graph 2 is not symmetric, but I guess okay.
Yeah, if it is symmetric, then there will be a problem. Yeah, I understand that. Yeah, true. But
So only one
will
thing, yeah,
sorry
you have
to
to
interrupt.
see,
Yeah.
you have to see that if x is tends to infinity, how does that graph behave? That can be seen from the graph. But if they have not given, only the plot has been given till 1, then you'll get confused.
Yeah. Okay. Yeah, true. Okay.
So I'll just start from the, okay, so where was I? So gamma is done. So similarly, the beta can also be there, like beta can also be represented in a similar way.
Okay.
So this is a different one. So yeah, so now we are having the beta. Okay, for the beta, the problem is not the problem, the only the codomain or the domain. Sorry, the domain for the x or the value that you will put for the x will always be like from 0 to 1, 1. So that is the one thing that you can differentiate from the any other what you can say, the distribution.
Right. Yeah.
Yeah, and the mean and variance are like that you need to mug up only. There's no other method to what you can say mug up. Like
So these things will not get in the exam, because even sir has said that we are not expected to remember everything, because everything is available on the internet and
yeah,
everywhere.
right, correct.
So
yeah, so if they're asking you, they'll give you all the information. Okay.
Right.
Yeah, so not to worry about this, like how does that beta and all. Only a basic intuition, how does the plot will be seen of the beta or the gamma and those sort of things.
So just to reiterate, sir, in case in certain cases where these values can overlap, there are chances that we'll not understand the distribution from just the shape, right? So there can be certain cases where it can
there
overlap.
can be certain cases that I told you, like if you're having function and they've just plotted you from 0 to 1, then for that the mean is lying between 0 to 1, then you'll get confused. Okay. But I don't think so they'll ask you those questions.
Yeah, I understood that. I'm just asking for the information.
Yeah.
Thanks.
So these are just the properties. There is not much in this. Like these are just properties. If you are able to remember, it's fine. If not, that is also fine. will get all the information. You just have to know, okay, if I'm adding this or an exponential, what is the final result of that? If you're like, for example, there are some other examples also like in the final one. If you're having this normal distribution, okay, this X bar will also be a normal distribution. This sort of things you should be able to like know that is it for, I guess, this and other if you are having if you're having some identically independent variables, random variables, okay, then the square of those will behave like a gamma distribution. So those sort of things you should be aware. Like if your X is a normal distribution, then the square will behave as a normal. And if you are doing the summation of all that, then you'll get a gamma only with the value, with the value will get changed. So I'll just write some important thing there, maybe that you can remember, or if you want to note down that you can note down.
Right. So one query, I mean, maybe a basic query again, where in the actual application where this will come into picture, like why we should know these shapes and how it will help us, like
I told you, if you are the gamma, generally, if you are having some n exponentially decaying or exponential distribution function, and if you're adding those, so like for example, if you're having one example, like anything is behaving in a exponential distribution, like if somebody's if some postal person or the clerk generally talks to us one person, if he's going and putting or giving the postal card to each and every like customer, or you can say whatever the addresses he has got. So if that is behaving in a, if he's just talking to one customer, and if that is behaving in an exponential distribution, just not the exact one, but just a brief, not a simple example. So if that postal clerk is talking to going to one home and is talking to that person, so the number of minutes he's talking to that person or the first customer is behaving in exponentially some decaying or exponential distribution. And if he's talking to some n number of customers, okay, and then if somebody has talked about to know regarding the statistic behind summation of the minutes or some sort of things like that, then you can directly continue with the gamma distribution, right?
Okay. Fine.
That's the one intuition behind it, but it's not the exact one because I can't recall. Like I can't recall any. I was just going through one example, so I just told you that one. Yeah. Okay, so I'll just write some important point maybe, but those are already in the slides. So the gamma. So one important thing is if xi's are some normal distribution with some sigma square, and if you are doing the x square, xi square will behave in a gamma distribution, right? So maybe you already know about this, right? Some 1/2 sigma square, and if you are adding this, like this x squared, sum of a squared of some normal distribution, then it will start behaving in a gamma only, because you already know if you are doing the summation of some n gamma, so that will behave a gamma only, but the shape will get changed up. So if you're having this, so it will also behave in a gamma only, but the shape will get changed here. So it will be now n. So n/2 and 1/2 sigma square. Or what are the other cases? Like there are some other cases. If you just go through the slides, also you go get to know what are the other cases. Okay, I'll just go through the questions itself. So I don't think so in the 8.1 you are having issues, right? So 8.1 is pretty simple. How to know the MGF, how to calculate the MGF. You just have to multiply the function with that probability thing, and you'll get the MGF function. Okay. So I don't think so. In the 8.1, there is nothing to discuss, right? Should I go directly to the 8.2? If you are having anybody is having any issue in 8.1.
Sir, question number 6 of 8.1.
Okay. So this is like for the sixth moment you have to calculate. So you already know how. No. Okay. So for that you have to, what you can say, how generally write the MGF of normal distribution.
Sir, sir, I have a doubt in first question. How to find centralized?
How to? How to? So this you can MGF of what normal. What is the MGF of normal? You can write it in this form, right? And if you like expand this, you have to expand this. How generally you expand the exponential of x, and then for the sixth or for the whatever the nth, you can just compare this with what lambda. If you'll just expand, how generally expand? What is the formula for that exponential of e to the power x? That you have to expand, and then you need to check the if that is asking for the sixth moment, right? So you have to see regarding the lambda, what is the coefficient of that if we are having there x. So you need to check the exponential for the x square. Are you getting my point? So you need to expand this. So there's some basic formula for the exponential of x, that is, I guess, 1 upon x factorial upon 1 factorial per x square by 2 factorial, some sort of things. You need to expand this and to compare the value of 6, what is the coefficient that you are getting. Did you get the point, or should I write it?
Yeah, just a quick question, sir. Coefficient of which part? Like, should we take lambda to the power 6 or like what?
No, because here lambda is already squared up. So if you are having e to the power x, then you will see for the x6. But here you are already having the lambda square. So you'll just check for what? The squared of that.
Sir, just one thing. But we won't be having the odd power of lambda now, would we?
No, you won't be having. So they're asking for sixth, right?
Yeah, but sir, just a clarification. So there won't be a third moment. Like there will be only even number moments. Is that it?
Okay, if you're just explaining, okay, if you're just expanding this one, so there can't be any.
So there can't be any odd powers.
Lambda square whole cube. That should be lambda to the power.
Yeah, lambda square whole cube, right? Because you're saying for the x, so there will be, right? So for exponential e to the x, you are checking for x cube, right? So here you will see for lambda square whole cube for the third moment.
So third moment of this term.
Yeah.
Do we actually have a third moment, or shouldn't that be 0? Like we are not having a third moment per se. There is no lambda to the power 3 there. Is there?
No, lambda square to the power 3 you have to check, right?
Actually, just suppose that x equal to lambda square sigma square by 2.
See, yeah, x, you can see if you are comparing with the exponent e to the power x, here x generally represents what? Lambda square, or
assuming x equal to lambda square sigma square by 2, then put it the value in the expansion of e to the power x. That is 1 plus x by 1 factorial plus x square by 2 factorial. So if we put x equal to lambda square sigma square by 2.
See, so you'll just write in this form. If you are having, say, for example, e to the power what? X. So how will you write this? This will write 1 upon plus
x plus
x
plus square by 2 factorial
cube by 3 factorial
and so on.
x cube by 3 factorial. Similarly, like this. Okay. So what is the coefficient of this x to the power 6? So the coefficient of x to the power 6 will be what?
So actually, we don't need x to the power 6 because here lambda square. So if we put lambda square whole cube, then we get lambda to the power 6.
lambda.
Lambda to the power here x equal to lambda square sigma square by 2. So if we put x equal to lambda square sigma square by 2, then we get the coefficient is 1 by 3 factorial.
Yeah, so you just have to replace this x with lambda square by 2 sigma square, right? Upon what? 6 factorial.
Sir, actually whole to the power 6. So that's not lambda.
Yeah,
to the
what
power
is the coefficient of what is the lambda? The coefficient of lambda to the power what is going to give me the moment, sir?
Okay, I'll just write in the. I'll just replace this exponential of x. I'll just write the exact thing. Okay. So if you have to what? This is the exponential. It is about lambda x, right? If you'll expand this, you need to get the sixth moment. Okay, I'll just give you a brief about that. So if you have to, so this is what, if you'll just expand this exponential of lambda x, so it will be what? Lambda to the power factorial x.
plus lambda x square by 2 factorial.
Sir, this is for normal, right? So we can replace right with e to the power lambda square x square by 2. We can do that, right?
Yeah. So this is what I'm doing. So you can just replace this by 3 factorial. Similarly, you will get for. So similarly, you can compare. Like for example, if you need to get for second one. So here what? If you need to get, like for example, what? Lambda x to the power 4 upon 4 factorial. So similarly, you can expand this. Okay. And then if you need to get for like for first moment is okay, pretty simple. For like for example, fourth moment. So there's a 4 factorial. And sigma here is what? So this should be lambda to the power 4 exponential. And then x will be what? X will be lambda sigma square by 2. Sigma square, okay. Sigma is how much for this question? What is the sigma value? Okay. Sigma square is 3. Okay. Am I missing something or what?
Actually, sir, there is lambda square sigma square by 2. So how to calculate the lambda square? This is lambda to the power 4.
What lambda square by? Okay, I'll just write it. So the question, the normal of 0 ka root 3 ka sigma is root 3 or whatever, sigma square is 3 here. So we need to get the exponential of what? We need to get the coefficient of what? Lambda. If we're having just expand it. So x here is what? Lambda square into 3 by 2 for us. Okay. So you need to get the coefficient of x at like what? To the power 6. So here it will be 6 factorial. And what is the upper?
Should that be x to the power 6 or x to the power 3, sir?
That will be x to the power 6 for sixth moment.
So then lambda should.
But lambda to the power isn't 6 anymore, sir.
Then lambda should be 12. Lambda will be 12, I think. If we put x to the power 6, then lambda square into 3 by 2 factorial whole to the power 6. That fulfills the value, that is lambda to the power 12.
What can you repeat that?
Here we need to compute the coefficient of x to the power 6, right?
Yeah.
So if we put lambda square x equal to lambda square 3 by 2, then we get lambda to the power, after the calculating, after x to the power 6, then we get lambda to the power 12 into 3 to the power 6 by 2 to the power 6. Is that the sixth moment, or question is lambda to the power 6 is the sixth moment?
Okay, I got. Okay, 1 second. Okay. Okay, so see what happens generally. If this is represented in this form, okay. So if this is represented in this form, so generally the coefficient of lambda will give us the moment for first, like the first moment, right? So the coefficient of here lambda square will give us the moment for second, right? Are you getting my point? Like the coefficient of lambda will give us the coefficient of lambda will give us the moment for first, and the coefficient of lambda square by 2 factorial will give us the coefficient of second moment. Sorry, the second moment.
So coefficient of lambda to the power 6 by factorial 6 will give us the sixth moment, is it?
Yeah. So the coefficient of lambda to the power 6. So lambda to the power k upon k factorial. So the coefficient of this will give you the sixth moment.
Kth moment.
Sorry, kth moment for this case. And so whether it's a 4, 5, or 6.
So, sir, I think for this expansion,
Yeah.
third moment is the sixth moment of this question. Accordingly, I think.
No. So the lambda to the power 6.
So we'll be getting odd powers of lambda here.
Not odd, even we'll get, right?
Yeah, so sir, there will be no odd moments, like the third moment or the fifth moment or the seventh moment will all be 0, except the first moment.
So if you have to calculate the third moment, so the lambda to the power 3 upon 3 factorial, the coefficient of this will give you the third moment, right?
Yes, sir, but are we getting a lambda to the power 3 here? That is the thing.
Okay, so no, we are not getting, right?
Yes, sir.
So we'll not get the third moment.
Actually, here x equal to lambda square into 3 by 2.
Yeah, so you'll get the second moment. I guess fourth you'll get, sixth you'll get. I guess maybe I'll not. I need to check it again. But now what I can see is we'll get the second, we'll get the fourth, and we'll get the third or sixth, right? Can somebody correct me? Okay. So yeah, this is what I think so. I think so we'll get only second, fourth, or sixth, eighth in the multiple of 2. But I need to check it again. But here what I can see is you'll not get the third moment or the fifth one and all.
So are we trying the sixth question still?
Yeah. So sixth question. Yeah. So I told you for the sixth moment, you need to.
It's normal 0, 3, no?
Yeah. Yeah. So this is what the coefficient of lambda to the power 6 upon 6 factorial will be your the
That's
sixth moment. Yeah.
Right. But the question given is normal 0, 3, no?
Yeah,
Sixth
normal 0.
moment for the normal 0, 3 only we have to find it out. Is that right?
Yeah, yeah. So you'll be having what? Root 3 to the power what? 6 upon 4 factorial.
6 factorial.
Sorry, 6 factorial into 2. So how much you are getting? 3 into what? Sorry, this. So this one, how much you are getting? 3 upon 2. How much is this? Are you getting wrong or?
Integer, not integer.
3 into 3, 27.
27 by 2.
Is this correct or not?
405.
Okay.
So it is 405, sir.
Okay. What mistake we are doing?
Calculate one thing, root 3. Just a minute.
So here the sigma is how much? Sigma is root 3 only, right? Sigma square is 3. Okay. Then we are doing the right thing, right? I don't know whether we are doing some mistakes in the sixth value, sixth moment. Okay. What's the mistake we are doing? Okay. Can somebody point out, or should we go in some other question? Maybe in the end we'll see this.
Yeah, sir, let's see this in the end, sir, please.
Yeah.
Sir,
yeah.
For 8.2, I would like to ask some basic questions, sir, because in 8.2, I'm facing some difficulty understanding.
8.2
lecture, sir.
Okay, so 8. Okay.
Sir, when we say x1, x2, x3, so on are belongs to xID, what does that mean? Can you explain exactly?
In which question?
No, not question, but
okay.
The general concept for the lecture itself.
Okay, so x1, x2, xn till whatever the xn, if that tells you that belongs to some density, some distribution, and that distribution can be anything. Like for example, that distribution is simply that distribution generally represents this one, like that. Like for example, a player is playing a cricket, or simple example is throwing a dice. Okay, and the distribution can come as what? 1 to
6,
3, 4, 5, 6, right?
Yes, sir.
With all the probability 1/6, right? So this is the distribution we are having, and
yes,
we can
sir.
say that we are having xi to xn distribution, and that belongs to this distribution. That means all the xi, I'm having n dice, and I'm throwing all the n dice. Okay, so all the outcomes, like the outcome of xi is independent of xn, and all the independent is identical. It's not depending on the xn. Like the first dice, like for example, this is the first dice I'm throwing, this is the second dice. So I'm throwing both the dice in different room. Like for example, this is one room and this is the other. This is not dependent on the other one, right? And
okay, sir. So x1 can be 1, 2, 3 or something. So x1 and so on to xn are distributions.
Yeah.
They are so when we are saying sample mean, we are taking so let's suppose say x1 is 1, 2, 3. So the sample mean will be 6/3, right?
Okay. So you are saying x. So x1, x2, x3. I'm 3 dice I'm taking. Okay, and the 3 outcomes in the first sort, I'm getting how much? 2, 3, and 4.
Okay, sir.
So the x mean is what? x1, whatever the outcome of the x1 plus x2 plus x3 by 3.
So
Right?
x1 is 2. X1 is not a distribution itself. So x1 cannot be 2, 3, 4. X2 cannot be 3, 4, 5 like that.
No, x1 can't be in one because we have just thrown the dice one time. If we have thrown the dice 3 times, then it can be 2, 3, 4. And this can also be 2, 3, 4. And this can also be 2, 3, 4.
Okay, so x1 is a single element of that experiment.
Yeah.
That is what I am struggling to understand. But when we are, in the 8.2 lecture, when professor talks about mean, what is the sample meaning?
Sample means 2 plus 3 plus 4 by 3. Because the first sample, what we got out of x1, x2, x3, what we got the samples. We got the sample as 2, 3, 1, 2, 3, 4. What is the sample meaning? Sample meaning we have thrown 3 dice, and out of that 3 dice, in the first dice I got 2, in the second dice I got 3, and the third dice I got 4. So 2, 3, 4 I got. This is a sample.
Okay, sir. So once can you go to
and
the
see,
lecture?
Yeah, and this 2 is what? This 2 is coming from this parent distribution. 3 is also coming from the same distribution, and 4 is also coming from the same distribution. Because all are same and having the same distribution implies this is x, for example, and this x is having this distribution, or this can be x can be a normal or whatever you can assume.
Okay, so these are essentially like children of that distribution.
Yeah.
Okay, sir. Sir, once can you go to the 8.2 lecture? I have small doubt.
Okay. Lecture.
Yeah, 8.2 central limit theorem.
Yeah. Where?
So when we are approximating CLT, sir is talking about this one, sir. When we are talking about sample mean, he means to say that x1, x2, so on or xn are individual, individual parts of the parent x, right?
Yeah, you can say individual part, or you can say all are different, all are totally different, xi to x, but all are same. I told you I am having dice. You can't differentiate between both the dice. Both the dice are same, only x1 and x2, and both are having the same distribution like x. What was the distribution of x? And x was having this distribution. That was having, that can get 1 to 6 with all the probability as 1/6, right? So x of x till x or x2, whatever the dice or whatever the number of dice you are having, all are behaving in the same way, you can say.
Okay, sir, I got it.
And there is a sample of, yeah, so there is some sort of chunk or the samples I'm getting from x1, x2, x1. Yeah.
Thank you, sir. Sir, can we discuss 8.2 fourth question?
Okay.
Similar. In this fourth question, sir.
So the number of accident in a certain city is modeled by a Poisson distribution, Poisson random with average number of 9 accident per day. Okay. And then suppose that the number of accident on different days are independent. Okay. So see, so he has just explained you, like I told you here, the X is what? A Poisson distribution with lambda 9, right?
Yes.
So there is a Poisson distribution. So we have a X now. So we have a X now, and that is a Poisson distribution with lambda equals to 9, right? Now I'm having how many? So number of accident different days are independent. Okay. Independent of each other, and all the number of accident in each, what is that? And then using the central limits, find the probability that there will be more than 3,300 accidents in a certain day. So for one day, we already know per day. So this is a distribution for per day.
So both mean and variance are 9 because it's Poisson.
Yeah, it's the Poisson. So whatever the, yeah, so we are having the same, the mean and variance. Now it has been asked to calculate for what? Probability?
Y greater than 3,300.
X1 plus X2 plus all should be greater than what? whatever the value it is,
3300.
Okay, 3300.
Yes.
Right? So now, okay, so we have to calculate this. So one thing we know about
Sir,
the,
it's x1 plus x2 by 365, right? Because all the days of the year. Yeah.
it's asking for more than 33 accident in a certain year. So it's just asking for all the summation, right? It's not
Okay,
asking about the mean.
Okay, got it.
Right?
Yes, sir.
So if that is asking regarding the mean, or sorry, all the summation, so what you can do, one thing you already know. So if we are able to convert this in the form of CLT, then you can apply your basic stuff. Like the basic stuff means, now if you are able to convert this with some heat and trial in such a case that if this come in this way, this like for example, this represents y, and your y generally comes in the way generally we define the CLT. If you are able to convert this equation in that case, then you'll be able to convert that in a normal distribution, a standard normal distribution, and then you can use the basic formula of FG or the basic normal distribution formula. Did you get the point?
Yes, sir, but I'm not able to convert it. Can you proceed with that? First, we'll divide it by 365, right? To convert into y.
Okay, so I'll just write it again. So you already know all the x I till x365. I'm having n equals to 365, right? And all this behaves in a same way as the Poisson, right?
Yes, sir.
Okay. So now what's the value? So, okay. So y generally is what? That you define in the CLT is x1 plus x2. That should come in this form, right? If
Yes.
you are able to convert this in this form, then you can apply the normal distribution, right? So what is
Yes,
the
sir.
expected number of total accident in a year?
In a day, it's 9, but in a year, 365 into 9.
Okay. Why I'm asking this? Because we have to centralize that, right? First. Okay. So 365 into 9. So what is the number? Can somebody calculate this?
3285.
3285. So this is the number of accident, or you can say the expected number of accident, right?
Yes, sir.
Yes, sir.
So now you have to calculate probability this or this y, and here y is the summation of all the x. Should be greater than
3,300.
3,300, right? And now you have to convert this in the CLT form. So how generally convert that in CLT form?
Y minus n mu.
Y minus
N mu
mu,
divided by sigma
By
under root
sigma.
n.
right? The same thing you'll do this side also.
Yes.
Minus 3,285.
Y minus n mu.
Right?
Right.
N nu or whatever the value we have calculated. This is the value we have calculated. N nu or the mean value we have calculated already for the summation, right?
Yes, sir.
But
Yes, sir.
sigma is 9, sir, right? Here.
Sigma is root 9.
Sigma, okay, sigma I'll put it. So what do you have to calculate here? And this generally will behave in,
Normal 0 1.
so this will behave in normal 0 1,
0 1.
right? So what we need to get? So we need to get the, if some function, if probability of x greater than some x, that can be represented in some f, 1 minus fg of
Yes,
x.
1 minus fz.
Okay. So here, what is this? This is simply 1 minus fg of this one, right?
This one.
So this is what? 15 upon root, like sigma is how much?
3 root
3.
65.
3 into root of 365.
Yes, yes.
So this is 5 and this 1 minus fg of what? This 5
5
upon root 365.
Yes.
So if the value is given, it's fine. Otherwise, you need to check the G, what you can say, G plot. There is a chart for that, if the G function, that standard normal. So you can Google this form, this chart, G chart, and then you can see the value. Maybe you already know regarding how to check.
Sir, if
But
this type of
answer,
hello.
Yeah.
Sir, if this type of question appears in graded, will we be provided with the FG chart?
If the chart will be provided, yes.
sir,
But if
can we
not
simplify
provided,
this?
you will be
It's
provided the G chart. G chart, you need to see how to calculate the value from the G chart. So this is a standard, right? So if this is a standard, there will be some standard value already. So if in this exam, like here, it has not been given the answer, then
Sir, it is there,
Google
sir,
that.
in the starting only.
Okay.
But I'm not getting it, sir. Can you check once? 5 by root 365 FC.
Okay. So what is the 5 by root 365?
I think it's 0.6, 0.26. Yeah.
0.26.
So we have the value for this one.
We have the value.
Okay.
Yeah,
so
this is already there, right?
Yeah, sir. So 0.4.
1 minus 0.6, then 0.4, I guess, should be the answer.
Yes, sir. Now I got it, sir. Thank you, sir.
So this can be one way. Otherwise, if not given, you need to see the chart, like how to read the chart. You can just Google and can see how to read the G chart.
Sir, in graded, it's not given, sir.
Oh, it's not given, is it?
Yes, sir, it is not given.
Oh, then you need to see the G chart, I guess. Okay, you can just Google some G chart and then you need to. I don't have no. Okay. Yes, but all the question is in the G form, right?
There are 2-3 questions, sir.
Yeah, sir.
Number 3.
I think,
yes,
yeah,
sir.
in this question, I think.
Okay, so okay, only this question, right?
This one, number 1 question will be.
This is a boson led. Why is this one CO2? Okay, why? It's why. So you can just Google this. So this is the G chart and how to read this. Okay. Like for example, what was the value we have all now? 0.26 was the value, right?
Got it.
Yes, sir.
Okay, so if that is 0.26, what was the value? 0.26, right?
26.
So this is not the whole chart. Yeah, there it is. 0.26, there it is. 0.2 and then you can see 0.6, right? So you can just read it. 0.6026. Correct? So this is the way you can just Google it and can get, because this is a standard, so you'll get the same value everywhere. Okay. And if that is asked in the exam also, you'll be provided this G chart or the values for which the G will come. Okay.
Okay.
Yeah. So this the. So you can just Google it FG for the statistic and you'll get it. Okay.
Actually, I spent a lot of time on this question, sir, thinking that the FG is not provided, so it should be 0, and my calculations are somehow missing with it.
Yes,
Yeah,
same
and
with me
anytime
also.
if you'll get FG at 0, right? You already
Right.
aware of this. So if you'll get F0, so every time if you are getting F0, you can directly write half.
Right. I thought that only, and my FG was not going to be 0, so I thought FG is not given, so my calculations are wrong, and spent a lot of time on it.
Oh, but it's fine. But like if you are doing for the first time, it's fine.
Right.
Okay. So any other good questions in this one? We'll try to solve it. One is the left that I'll solve it in the end. I'll try to solve it again, that question. Anything else in this week? Any other questions that you want to solve? Like you are having any issue? Yeah. Anyone is having
Assignment
any?
4.
Which one?
Practice assignment question 4.
Okay, practice assignment, fourth question. Okay, so I'll just solve this third question. So what's the answer with this third question? So this was the questions, right?
Yes.
The third one we were struggling to solve, right?
Right.
Sir, worked it out. The sixth moment, it's 405. I got the answer. Thank you, sir.
You got the answer?
Yeah, sir. It's like.
How did you got that?
Sir, that was just trying to expand it. I was working it out while you were explaining that problem to the other gentleman.
So you got the coefficient of this one only, right? Lambda.
Yeah, absolutely. It was like lambda to the power 6 divided by 6 factorial. So
the coefficient of this one, right?
Yeah, it needed a little bit of manipulation, like multiplying by some 120 at the numerator and denominator and get it to factorial 6, and then like it was like okay, it was doable, sir. But essentially, lambda to the power 6 divided by 6 factorial. That's a coefficient I took. Thank you.
Okay. So every time, like if this is a fourth moment, you have to do it for the lambda to the power 4 and see the coefficient of this one. Oh, okay. Okay. Thank you. Thanks for that.
You're welcome.
Oh, so what was the question?
What is the technical name of sixth moment?
Technical name? I don't know. Maybe there will be some. I'm not aware of that. Second moment, I guess this power generally we represent in electronics.
Second moment is variance, I think. First moment is mean. Second moment is variance, like that.
Oh, okay. No, when I used to like when I was in the college, I guess when the power moment or something we used to say for the second moment or third moment. I'm not aware of that. So maybe you can check it on the Google or something. So what are the question for which question? Fourth one, right?
Question 4.
So okay, just tell me what are the. So the x is gamma.
Gamma 2,1/2.
So gamma
2,1/2.
And then
Y is gamma 5,1/2.
Five comma 1/2. And then what's the question?
We are asked about the expected value of x divided by x plus y.
Okay, so we have to calculate the expected value of x. So generally you already know that. See, this will converge to what? Some beta, I guess, right?
That's where I was struggling.
So this will converge to a beta. So if you'll just go through the slide. So if you'll just go through the last lecture or the second last. So this x upon x plus y, yeah, so there it is. So if you are having this x as a gamma with this alpha and this y as a gamma,
right.
So this will converge to a beta.
Okay.
So beta alpha, so beta with alpha and this, you can
beta.
say A and B. Okay, and where A and B is the, what you can say, the shape parameter for gamma A and B. So what is here? So 2 and 5. So simply you can calculate the expected value. And how then you calculate the expected value of beta? This is, I guess, the formula. 2 upon 2 plus 5.
Right.
Okay. Yeah. So this is the way. Yeah. Thank you. Anything else from this one? Any other questions? And one more question, I guess somebody asked regarding the variance, how generally calculate the variance for x and x upon y. Ganga, you have asked. I searched, I didn't get any answer regarding that. You can, I don't know how generally calculate the variance if you're having x upon y.
Okay, sir, no problem. I will also search.
Yeah, so because I don't know how to, if you are having variance x upon y, I don't know how we'll calculate that.
Okay, sir. I will try to figure it out, sir. Thank you.
And yeah, anything else from this? Like any other questions? You're having any issue in this?
Sir, one conceptual doubt. Like
Yeah.
at the beginning, we were discussing that each distribution is described with the help of certain parameters, right? Like
Yeah.
shape, rate, and other thing, location, right?
Mhm.
So, is there any guideline that which parameter to select for which distribution? Like normally described by mean and variance, right? But
Yeah.
Cauchy, gamma, and beta are described
I
by
guess
some.
this are all based on some sort of observation. I guess some sort of observation on which they have defined this two parameter. If this two parameter are there, we'll define this as a this distribution. Like if you are having this mean and variance in such form, I'll define this as a normal distribution.
No,
If I'm having
like in last session we discussed for quotient, so that is clear that only lambda is there, right? So with the help of
yeah,
with the help of lambda we calculate mean, and with the help of lambda we calculate variance, right?
yeah,
But
correct.
if I talk with respect to normal, so we are taking mean and variance, and then with respect to beta and gamma and Cauchy, so different parameters are being taken. So is there any guideline? Just I want to know. I don't have
There is
answer to this
no,
question.
like I'm not aware of such guideline. How will you define if you're having this parameter? Okay, but like but I can differentiate between some. If I'm having some distribution, I can differentiate with seeing the plot, or if I'm having the distribution function, I can differentiate on based on those. Like all the distribution mostly generally represent a different
So, as
plot.
such, no guideline.
Yeah, there is no such guideline where you can say directly.
Okay. Answer just one question related to moment generating functions. Like when we say that y, y is a function of x1 plus x2, right? Like x1 and x2 are different random variables, and then we define y as x1 plus x2, correct?
Yeah.
So while calculating MGF of y, we square it up. So why do we square it up? Like
because see, MGF is generally defined as the expectation of that. What you can say? Not the expectation. Generally, we say MGF is what? A function like R2R function, right? Where the function generally has been converted to a MGF function, right? In the form of exponentially lambda x. But when you are doing the addition, when you will do the addition, if you'll do the addition in the exponential, that will get converted into a multiple, right?
Okay, got it. It will be called lambda x, na? So
yeah.
It is y
if you're writing that exponential of x1 plus x2,
yes,
that will get converted into a product, and then that's why generally we
sorry,
multiply.
sir, it was clear to me. Sorry, by mistake. And then one more thing, sir. Okay, continue, sir. I will ask this.
Okay. So yeah. So anybody is having any issue in any of the questions, activity question to practice? So if you're having any doubt, you can ask me. We'll just discuss it.
So now may I frame my question, sir?
Yeah,
someone is not asking anything.
Yeah, sure.
So like we started talking about MGF for the first time. Like first of all, we talked about Markov inequality, right? When we say that mean is x is greater than t, right? And from Markov we move to Chebyshev, and then we move to Chernoff, right?
Correct.
So there we say that in order to make it positive, we are squaring it, and that is becoming Chebyshev. And then what are the other functions which can make it positive, right? So in place of taking it exponential function, why we didn't go for mod function when we could have taken mod function also, right?
This all like there is no such why we have done x square, why didn't we do mod, why we are doing x cube. These are all based on some sort of researcher has done some observation. Like for example, Chebyshev is what? Chebyshev or Chernoff, what are those? They're just the
empirical kind of thing.
Probability. Okay, go.
So empirical kind of thing. What you are saying? Empirical.
Yeah. These are all clinical trials, hit and trial method. So they have just started with some Markov's inequality. So they just wanted to bound the probability function. they've started with the Markov's, Chebyshev, Chernoff. But with those cases, they have calculated some probability stuffs. Okay, they have bounded some. But when we went through the exact value, they were like the values, the exact probability value was very much far from the whatever the foundation has. The foundation was correct every time, but the exact value was very different from that final value. Okay, so that's why they've started doing some other random stuffs. They've started doing skew, square, whatever, like they've done some MGF functions. So they have just started exploring.
So the history behind
CLT also we got in the same way.
Correct.
So we have got the CLT also with the help of some observation, some clinical trial, and also they started doing with root n. And with root n, they got for each and every function that MGF was a parabola. Okay, not parabola, some sort of quadratic equation they were getting. Okay, and that quadratic means it is getting converted to a normal distribution. So that was a big breakthrough in that observation. So we can't say why we are not dividing that with n to the power 3 by 2. Yeah.
Sir, just a clarifying question, sir. So, so the moment generating function, the origin is from those inequalities only, na? Like from Markov.
Yeah, so those inequality, yeah, correct.
Those lead to generate MGF, right?
Yeah. So this our starting point is from here only. There,
Markov.
Yeah, Markovs. Yeah, we can say the Markovs is the starting point of everything.
Okay.
Okay, so most of you, like, whether you have tried this or not, like have you went through the solution? I'm saying, have you went through all the problems? Have you tried solving this, all the questions? Because the conceptual part, I guess, has been discussed. I can understand this what do you say? This week is pretty difficult from the others week, because of the CLT and there are so many distribution has been talked, and those distribution has not talked in a greater detailed way, because that is not important. Only some of the chunks was important. That's why it has been discussed just a brief about the distribution. So I can understand it's a bit difficult, but if you start trying to solve some problems, I guess that is not that difficult to solve the problem. Maybe you can write some, what are the big, like, see, from the first lecture, only the MGF is there. So MGF is pretty simple. CLT is a bit difficult. Okay, so you can just leave it for some time. Third, if you'll come to third, only distributions and properties are there. You can just write all those properties or distribution in one page. There are 5 properties, I guess, in the third and fourth week. Then you can start solving the problem. So I don't think so you'll not be able to solve those problems. Only the problems 8.2. So for the 8.2, just go through the lecture. Okay, you're already clear with CLT. Okay, you have to convert everything in the form of that CLT form, such that you'll be able to apply that normal distribution. Okay, that this concept is pretty clear. Only the difficult part is how to apply them. Let's start with the first question. Just try to apply there if you are able to. So just try to, what you can say, first the basic step is to first normalize this thing. After normalizing, you should be aware of what you have to calculate. If you have to calculate probability such that x is greater than 500. Okay, so you're already aware of this. Okay, it's x is there. You have to calculate x greater than 500. Now, everything you are having in the form of what? Summation of x plus root n. So that you have to calculate in that form, not in summation of x, like summation of x minus that mean value upon root n into sigma. So that you have to convert in both the LHS and RHS. And then you can directly convert in the FG. And I already told you how to read the FG, and after reading that, you will get the answer. Only problem is the hit and trial method. In between, how will you convert that in the different form? Okay, for that you can try like 3-4 questions are there. You can try that one. You can ask on the discourse. If you are like, if till now, if you have not solved, you can ask on the discourse. Somebody will solve your problem. You can get a bit idea about that. Then you can start solving the practice and then the graded. The graded, I don't think so there is much problem on those. It's only you are having in the practice itself, you are having so many problems that, like, the first question, okay, the second is pretty simple. Okay, the third one is based on CLT, that can be solvable problem. The second is pretty simple. Okay, fourth is also okay. Most of the cases are okay. Fourth one can be solved with the properties itself. So you don't have to use much concept. Okay, normal evaluate this. Okay, here you have to use both the concept of CLT and that will get converted into gamma. Okay, one problem is a bit difficult. Okay, and then this is the gamma variance is given. Some of okay, so all the hint is also given here. Okay, so this you have to try some hit and trial, and then you need to get the, I guess, the value of n you have to get. Okay, and then same process you have to apply here using CLT, and other was the V law of large number. Okay, so and here what is okay. So if we are able to solve the practice assignment, most of the question, the graded is also on the similar pace. Like for example, if you go to the practice assignment from the first question itself, okay, the first is this will get converted into some different distribution that you can just go through the properties of the distribution. What does that x upon? So can somebody tell what would the like x upon y? How does that will behave? Which distribution will be there? If you're having x and y is a normal, how does that x upon y will behave? What? They will behave in a Cauchy inequality, right?
Yeah, Cauchy.
Cauchy distribution. Yeah, Cauchy. The second one is what? Second one is totally based on CLT only, right? So here you have to calculate the expected mu value you can calculate. And then what is that? A study shows that average number of this. Okay. So for one case, for one day it has been given, and for one thing it is sample of 100. Okay. So again you have to do this for the summation. Okay. So here you have to use the concept would be same. Yeah, the concept would be same. Again, you have to use the same thing, the CLT concept only, right? Like for example, if you are having this case, has somebody solved this question?
Yes, sir, I have solved this.
Yeah. So what do you have to calculate here?
Hold on.
X is what there? Do you want to solve this?
Number of hours teenagers sleep, that's what we are calculating x.
Okay, so you have to calculate here what? Probability of x bar minus mu. This is what you have to calculate, right? So it's at least should be 0.4 hour away from the population, right? This is what you have to calculate. Okay. So if you are having the sample is what 100 is there, say this is what, so y can be written in the form of this x1 plus x100. Now you have to this, you can convert this in what? This is what s or y, whatever you want to know, x in new. So you have already n is there, sigma is there, n is there. See, so you can calculate population mean has been given. So the same thing you can apply in the RHS also. But here there is a trick, like whatever you will calculate, just divide it by 2, like because you have to get it both the cases, right? So you have to get this cases also, this cases also. So if you are getting, like for example, probability of in the end, if you are getting some, like for example, probability of y greater than equals to 1. So you have to add for both the cases, probability of y greater than 1 plus probability of y less than -1. Okay. So this is the only trick that you have to apply. Only one thing you need to do is you try something, and so whatever you are trying on this left side, you have to try the same thing on the right side. Okay. And if you are trying on the left and right side, this left side will get converted into normal distribution, and the right side you can directly apply the FG, right? So this is the one like method. In a similar way, you can solve the third question also. No, the third
in this second problem, had it been like within instead of is at least 0.4 hours away from the population mean. Had it been within, then how would we have handled the inequality?
Then you can directly, whatever the year get, you can directly minus this.
Okay, okay.
Yeah. Or
okay, so that 1 minus fz2, I subtract that from 1.
So what is the final value you got?
So 1 minus of fz2 plus fz of minus 2 plus fz of minus 2. Yeah.
This you got. So this you can do. So
okay, got it. Thank you.
Or from, so if you are getting this one, right? So this is a bigger equation. So here itself you'll get what? Probability of some y bar less than equals to 1, right? This is what you will get. Correct?
Yes.
So this also can be written like this is what? If you are having some mod x less than equals to 1, that means what?
Yeah, I got it, sir. Like there are two ways we can do it. Either we do it this way and then subtract from 1, or
From the starting you can
got it.
Yeah, so anything else from this week? So this also is a MGF problem. I think so. Most of you have not solved like this. Maybe because today was the exam for some, or there can be some other reason also, but I don't think so. You have already solved this week problem.
No, sir. Understanding concept took too much time.
Okay, so maybe I don't know when is your next session. You can, because if you are not able to, Wednesday is
Tuesday.
But Tuesday is the solve with us. You can't ask much questions in that. So okay.
But
Wednesday.
what the concepts?
So if you face any issue, you can just ask on the discourse. There's no other method, I guess, now, because
No, sir. What the concept, sir? So now I can solve.
Yeah. Okay. Cool. Anybody else is having any issue in any of the questions, you can ask. Otherwise,
You can call it a day, sir.
what?
We can call it a day. There is no question.
We can
wind it up. We can wind it up. We can wind this up.
Yeah. We can wind it up.
There is no question.
So So I guess how many of you were having today was having some exams? Okay.
Sir, you also teach MLF, right?
Yeah.
What part of do you teach statistics or math over there, sir?
It's like linear algebra is there.
No. What portion do you teach, sir? Maths or statistics? Just for knowledge, I'm asking, sir.
Okay. So generally, me and one more person is there who teaches whole of the courses in MLF.
So entire both math and statistics both.
Yeah. So okay, 3% was having that exam. Okay. Okay, fine. Okay, then if you not have, I'll just ask them to close.
Yes, sir. Yes. Thank you, sir.
Okay, thank you.
Thank you,
everyone.
Thank you.
Yeah,
Thank you,
sir. Yeah,
Thank you,
thanks
sir.
everyone.
Bye.